All right, so in this question, we are given that a man is on an island that's 4 kilometers from the shore. So let's draw that out. Let's assume that the man is right here on the island right here, and this is 4 kilometers away from shore. And then there's a corner shop or a corner store, which is 8 kilometers down the shore. So basically, there's a shop over here that's 8 kilometers away. And the man wants to get to this store in the quickest amount of time possible, and he can row at a speed of 3 kilometers per hour, and he can walk at a speed of 5 kilometers per hour. So if you think about this question, if he goes straight over here and goes all the 4 kilometers and then he walks all the 8 kilometers, it's not going to be the most efficient. And if his row speed and walk speed were the same, he would just row straight there because that's the shortest distance. So very likely the ideal situation is he rows at an angle like this, somewhere here, hits the shore, and then he walks the rest of the way. We know that this distance is 8 kilometers over here, and we need to find where on the shore he's going to land in order to minimize the time it takes for him to get there. So what we want to do in this question is we want to break down this side over here into two different things. So let's say, for example, I call this as x, and since the total is 8, this little distance here is going to be 8 minus x. Okay, so now we want to do everything in terms of time. So I know that the total time it's going to take him to get to shore is the time it takes for him to row till here, then the time it takes for him to walk till there. So I'll call that T1 and T2. T1 is basically this time and T2 is this time over here. And once I get an equation for this, I want to derive this equation because I want to minimize the amount of time. That's the goal for this problem. So in order to find time, I know that speed is distance divided by time. So if I rearrange this for time, time is distance divided by speed. Let's talk about the first part of his trip over here, which is over the water. To find this distance here, I actually have to use Pythagoras theorem in this triangle. So c square equals x square plus 4 square. So c equals square root of x square plus 16. Okay, so that's the time over there, which means that, the distance over here. So distance divided by speed means that I'm going to write this as an exponent of half as well, because that's going to be easier to drive. So that's my distance divided by my speed, and a speed over water is 3 kilometers per hour. So I'm going to divide this by t. And then let's do the walking time over there. So the distance over there that he walks is 8 minus x. And the time, the speed of his walking is 5 kilometers per hour. Now that I have an equation in terms of t, I want to derive this equation, but before I derive it, it's actually just a bit easy to simplify by splitting this denominator here. This makes it a bit easier to derive. It's not necessary. As you get at deriving, you don't need to do this step, but I'll just do it so that it's a bit easier to see the derivation. So now let's derive this equation. I'm going to bring my exponent down. 1 over 2 times 1 over 3 is just 1 over 6. This is going to turn into the same thing, x squared plus 16. My new exponent is going to be negative half because I subtract 1. And then because of my chain rule, I'm going to multiply by the derivation of the inside, which is just 2x. The derivation of a constant is 0, so 8 over 5 disappears. And then the derivation of negative x over 5 is just negative 1 over 5. So now we just want to make this equation equal to 0 and solve it. You can simplify over here. This 2 cancels with this 6, and I'm just left with a 3 down there. And I can rewrite this as x over, I'm going to move this all to the bottom and make the exponent positive. So 3x squared plus 16, 3 came from there, by the way, the power of half minus 1 over 5. Now we simply have to solve this equation and find our value of x, and that will minimize the time. It'll tell us where he has to land on the shore to minimize the time. So I'm going to start by moving the 1 over 5 to the other side and making it positive. Then I'll cross multiply both sides to get rid of my denominators. Next, I'll divide 3 on both sides to get rid of this 3 over here. I'll square both sides to get rid of the 1 over 2. And I will subtract the x square on this side over here. Just that way I have my x square terms on the same side. So 16 equals 25 over 9 minus 1 is just 16 over 9x squared. And then because 16s are multiplied on both sides, I can cancel that out. So I have 1 equals to x squared divided by 9. Multiply the 9 over, so 9 equals to x squared, and then I square root, get x equals to 3. I don't have to worry about the negative solution, because the negative solution means it's going to go all the way down here, and then we know that's going to be a longer time. So you only have to worry about the positive solution in this question, which is 3. So basically, we know he has to land 3 kilometers away, or actually 5 kilometers away from the store, because 8 minus 3 is 5. So 5 kilometers away from the store. That would be his landing point. And if he lands over there, it will minimize the time that he takes to get from the island to the store. If you had to find the time, you could plug in the x value of 3 into this equation over here. You could calculate this. It would actually tell you the minimum amount of time as well. If you want, actually, I'll do that really quick. So t equals 9 plus 16 is 25. 25 to the power of half is just 5 over 3 plus 8 minus 3 is 5. 5 divided by 5 is 1. 5 over 3 plus 1. Basically 8 over 3 hours, or 2.67 hours. Around 2 hours, 40 minutes.